So as was on the video, we're going to talk about the law of cosines today. So the law of cosines, you know, it's used for side, 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 and side angle side cases. So on the video, they just gave you one formula. Okay, now that one formula can in fact be used to solve both cases, but I'm going to give you a second formula that's a little easier to solve. Okay, so first of all, the side angle side case, this was the one taken from the video. Okay, derived from the Pythagorean theorem. It's used to find side C opposite a given angle C. Now, it doesn't just have to be used to find C. It could be used to find A or B, something like that. And so, we're going to go ahead and write some other formulas based on this. Okay. If you notice, the C's match. And then we're going to use sides A and B. So once you get that down, I want you to think, how could we solve that for A squared? How could we solve that for A squared? So what would A squared equal?
C squared.
Yep, B squared plus C squared minus 2BC. I'm just doing BC because it's alphabetical, times the cosine of what? A. So we see how those match?
No.
Okay, A and A. Your side that you're trying to find A will always match your angle A. So, this and this will always match. Okay, the A's will always match. So let's go ahead and try and find, let's go ahead and try and find B. So let's do B squared. What would B squared equal? Yep. A squared plus C squared, keep going.
Minus 2AC.
2AC times the cosine of B. So that's for the side angle side case. So that's when you know two sides and the included angle and you want to find the other side. So now what we're going to do is we're going to go ahead and look at the side, side, side case. Now the side, side, side case, this is basically the other formula that we just got done looking at, but it's solved for cosine. Now, when we used the other formula for a side, side, side case, there are usually a ton of mistakes that get made in finding that angle. So we're going to go ahead and just use this formula. This will be much better. Some things I want you to be aware of. Some things I want you to be aware of and see how they match. Once again, whatever angle we are trying to find. Yep, whatever angle we are trying to find matches this right here. Okay? Whatever angle we are trying to find matches that side right there. Notice that that side that matches the angle is only used once. The other sides are used twice. So let's go ahead and jump in with an example. Okay? So, alrighty, here's our example. Solve triangle A, B, C. Solve triangle A, B, C. So in this problem, what do I need to find for my answers? Angle A, grab the pen. Angle A, angle B, and angle C. Those are my three answers. So when all is said and done, I want to find those three angles. So what I could do is I could start with a diagram if I wanted. I don't have to, but I could. And my diagram could be something like that. A, B, C. Side A is 8. Side B is 19. Side C is 14. Okay, it doesn't have to be perfectly drawn, but that's what we could do. So the thing, what you always want to find with the law of cosines is you always want to find the largest angle first. when you've got a side case, you always want to find the largest angle first. If you find the smallest, you're going to run into trouble, possibly. Okay, so largest angle would be opposite what side? B. Okay, so B opposite 19, right? So this is the angle I'm going to find. So my formula is going to be cosine of angle B equals. Now what number am I only going to use once? 19. The other numbers I'm going to use twice, and so I've got 8 squared plus 14 squared minus 19 squared divided by 2 times 8 times 14. Now if you're doing this on your calculator all in one step, what you need to make sure that you do is you need to make sure you put the numerator in parentheses and then divide it by the denominator in parentheses. Otherwise you're going to get something that doesn't match up. I want you right now to do that on your calculator. Tell me what you get to 4 decimal places. So I'm looking for 4 decimal places on this. Make sure you use parentheses around the top and make sure you use parentheses around the bottom. And what do you get? Yep, 45089, which would be 0.4509. Now, when you solve this, once again, I want you to use the long number. I don't want you to just use these 4 decimals, but we have to do this because I have to draw the line somewhere when I'm writing these numbers up here on the board. And so now what I need to do is I need to go ahead and solve that for B. So how do you solve that for B? Inverse cosine, very good. So I'm going to take the inverse cosine of both sides. Now when I take the inverse cosine of both sides, I end up getting B to equal what? 116.80. Now since we're rounding to 2 decimal places, we do need to put the 0 in there. So angle B is 116.80 degrees. So I know that B is 116.80. Now the beauty of this problem is that you don't have to do the law of cosines again. Okay? Because obviously you can see the law of cosines is a little bit longer than the law of sides. So what I can do, since I right now have an angle-side combination, I can jump right in with the law of sines. So law of sines would be sine of 116.80 divided by 19 equals the sine of, do you want to find A or C? A. So sine of A over 8. So what I'm going to go ahead and do is multiply on the diagonal, divide by 19. Tell me what you get the sine of A to equal to 4 decimal places.
3758.
Point what?
3758.
3758. Did somebody else get that?
Yeah.
Okay, so now how do you find A? Inverse sine. So A comes out to be what, folks? 22.08? Good. So now we have 2 angles. How could you find a 3rd angle? Yep, 180 minus. So I'm going to find angle B by taking 180 minus 116.8 minus 22.08. And what does B come out to be? Oh, sorry, I wrote that wrong. It should have been angle C. That was my mistake. Sorry. Change that to C. So angle C comes out to be 41.12. Okay, so we've got 41.12 degrees. So those are your answers. Questions? Let's go ahead and look at another problem. A equals 115 degrees, B equals 15, C equals 10. So what do I need to find? Angle B, angle C, and side A. So what you could do is draw a picture if you wanted. Here's A, we could do A right here, 115. Here's B, C, so B is 15, C is 10. So now this is side angle side, you can see that. So we're going to use the law of cosines, and what are we going to find? Side A, okay? Law of cosines states that A squared equals 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 115. Now you should be able to do this in one step on your calculator. And so you're going to get A squared to equal a pretty big number. Mm-hmm. 451.7855. Now once again, we just want to use the number in the memory of our calculator, but this is just to let us know kind of how to do that. And how do you solve for A then? Square root that? Okay, so I'm going to take the square root of both sides, and A comes out to be what? 21.26. So A up here is 21.26. So now the nice thing is what? I can do the law of sines now to find angle B and angle C. What angle you want to find? So sine of 115 over 21.26 equals sine of, what do you want to do? B over 15. Multiply, divide, so you get the sine of B to equal what? Yep. 0.6394. Now how do you solve that for angle B? Inverse sine. And so angle B comes out to be what? 39.75 degrees. So angle B is 39.75 degrees. And last but not least, what do you need to find now? Angle C. So angle C will equal 180 minus 115 minus 39.75. So what does angle C come out to be? What?
25.
25.25?
Are you gonna give us the read? Because I found C first.
Yeah, me too.
And I got 25.23.
Yeah.
You got 25.23 when you found C first?
And then
Okay.
find B is 39.75.
10 sine 115 divided by 21.26, and then the inverse sine of that, and you get 25.23. Yeah, there's the fudge factor. Okay, remember I give you a little bit of leeway. So, and in fact, I think when we did this fourth hour, we did get 25.23 because that's why I asked you a second time, because I was like, I don't think I remember writing that down. So, there you go. Questions? The reason why there is a little difference is because of the 21.26, because we did round that to 2 decimal places. All right, so the very last things we're going to talk about are the area formula. So now we're going to look at how you can find the area of a side-side-side triangle and a side-angle side triangle. This is the last content we will be covering for the week. Okay, you've got a quiz tomorrow, you've got some group work, and you've got a worksheet for the rest of the week, in addition to today's assignment. So, Heron's area formula is used when you know the side, side, side in a triangle. So up until this point, you only knew the area formula for a triangle is 1/2 the base times the height. But then the problem is, what happens if you don't know the height? And so these next two formulas we're going to look at are going to take that into account, that fact. So as you're writing that down, I want you to think about what does S stand for. So look at S and think about. Do you notice anything in the formula for S? Yeah. Half the perimeter. So where would they get S from half the perimeter? Okay, whoa, right there. What did you just say? A semicircle is half of a circle. So what would be half the perimeter? Semi-perimeter. So S stands for semi-perimeter, which means half of the perimeter. So they didn't just magically dream up S and say, hey, we're going to throw S into this formula. They're saying we're taking the semi-perimeter here on every one of those. So anyway, let's go ahead and look at a problem that deals with that. It says find the area of a triangle with sides 43, 53, and 72. So 43, 53, and 72 meters. And our goal was going to be to find the area of that triangle. Now without this formula, we could get there. It's just going to be a lot more work. So first thing you're going to do is find the semi-perimeter. So 43 plus 53 plus 72 divided by 2. And you should get the semi-perimeter to be 84. Now the semi-perimeter should actually be the largest in the triangle. And so now to find the area, what you're going to do is you're going to take the square root of the semi-perimeter, and then what you're going to do is take the semi-perimeter minus each of the sides. So you're going to take the semi-perimeter and then the semi-perimeter minus each of the sides. There you go. Now, if you're doing this as one long problem on your calculator, you're going to need to make sure that you have parentheses around the whole thing. I actually simplify these individually, and so I know that this is 41, this is 31, and this is 12. And so then I'm just going to take the square root of 84 times 41 times 31 times 12. But you can do whatever you want. And so what does the area come out to be? 1,131.89. Label will be meters squared. That is the answer. Questions? Pretty easy once you have the formula. So now what we're going to do is we're going to look at the formula for side angle side in a triangle. And this will be the last thing that we cover today. And so if we're finding the area of an oblique triangle in which we know the side angle side, we don't have a fancy name for it. But here's the formula. 1/2 AB times the sine of C. 1/2 AB times the sine of C. So A is one side, B is another side, and C is going to be the angle between the sides. So one side, another side, and the angle between the sides. And that's where the side angle side comes into play. So let's look at a problem here. Oh, sorry, I skipped it. Go back. There we go. Find the area of the triangle with A equals 5, B equals 8, and C equals 40. So it might not be as easy for you to see unless we draw an example. So A is 5, B is 8, C is 40. Now my instructions are to find that area. So the area will equal 1/2 times 5 times 8 times the sine of 40 degrees. And, as I already heard somebody saying, what'd you go ahead and say it was?
12.86.
12.86. I don't have a label, so I'm going to go ahead and put units squared. So questions? So, law of cosines is used side, 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 angle, side. We've covered the area formula for side, 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 and we've also covered the area formula for side, angle, side of a triangle. Your assignment is going to be 27 through 42, 46, 48, and 50. Now, I know the 27 through 42 sounds like a long thing. The last half of those problems in that section are just area problems, finding the area of the triangle. So those aren't long problems like solving the entire triangle. So what you need to do, add this on to your existing 4-7. That lesson 4-7 is going to be due Friday at the start of class. I will not leave it till tomorrow night. Get it done tonight. Okay, quiz tomorrow, and probably going to have a worksheet. So